Hello, my name is Dr. Dan Wedding, and this is DrWedding, VB22, Reading and Writing to Serial Ports. This can be used for controlling Arduinos, Picaxe microcontrollers, and LCDs. I would appreciate it if you watched the entire video, liked the video, and commented on the video. But if you only want to see one part of the video, you can jump to the desired section using the index below. When computers first came out, and for many years after, computers had serial and parallel ports built into them. These ports were on the back of the computer and allowed external devices to be attached to the computer. The parallel port was a 25-pin female DB25 connector, and it was mostly used to connect a printer to the computer. The serial port was a 9-pin male DE9 connector, and it was mostly used for keyboards and mice. However, its use expanded over the years. It is easier to fool people than to convince them that they have been fooled. When someone learns something wrong, it is often much harder to convince them that they are incorrect, even in the face of overwhelming evidence. One prime example is the serial connector. The serial connector is a DE9 that many people incorrectly call a DB9. These plugs are D subminiature connectors, so they start with D. The second letter represents the size of the connector. The parallel connector is a B size, and the serial connector is an E size. Lastly, the digit is how many pins are on the connector. So the parallel port is a DB25 and the serial port is a DE9. So many people mistakenly call the connector a DB9 that you will need to search for both DB9 and DE9 to find what you're looking for. As time and technology advanced, the serial and parallel ports are no longer automatically on the back of motherboards. The space where these plugs used to be is now filled with USB plugs. That does not mean that serial ports are extinct. There are still COM port plugs on motherboards, and with a simple bracket, you can add one to the back of the computer. There are also serial port cards that can be plugged into the motherboard, and there are also USB to serial cables. There are not a lot of properties that need to be configured to allow you to use a serial port. When you are connecting to a serial device, it should have the parameters listed so you can configure your port to match it. Most of the time, you only need to know 6 settings: the baud rate, data bits, handshake, parity, port name, and the number of stop bits. All of the properties you will need can be configured in the Properties window of the COM port object. The baud rate is how many bits per second the computer will transmit and receive. Your computer and the external device have to be set to the same speed or your data will turn into gibberish. Some common speeds are listed below. You can change the number of bits that are in each piece of data. Again, both devices need to be set to the same value. Most of the time, this will be 7 bits or 8 bits. In the past, it was important to prevent 2 devices from talking at the same time, as well as eliminating errors due to electronic noise. There are 9 signals on the DE9 connector. The handshake setup determines how these signals are used for error checking and synchronizing. Because computers and devices are much faster and noise resistant than they were in the past, handshake is not as important as it used to be. Handshake is often set to none. This will only require 3 pins to be connected. Pin 2, the receive pin, Pin 3, the transmit pin, and Pin 5, the ground pin. To prevent electronic noise from corrupting the data, a parity bit was added to the end of the data. The parity bit can be odd, even, none, mark, and space. Assume you are transmitting in uppercase A. From the ASCII chart, the binary value for A is 01000001. When the computer is set to odd parity, the computer automatically adds a ninth bit, called the parity bit, to the end of the data. This ninth bit makes the number of ones in the sequence odd. In this example, there are 2 ones in the data, so the parity bit is automatically set to 1 to force the total number of ones to be an odd number. If the equipment receiving the transmission does not receive an odd number of ones, it will stop the transmission and ask for the data to be resent. When the computer is set to even parity, the computer automatically adds a ninth bit, called the parity bit, to the end of the data. This ninth bit makes the number of ones in the sequence even. In this example, there are 2 ones in the data, so the parity bit is automatically set to 0 to force the total number of ones to be an even number. If the equipment receiving the transmission does not receive an even number of ones, it will stop the transmission and ask for the data to be resent. When the computer is set to none, also referred to as no parity, this error checking feature is disabled. Mark and space are a lot less common. When the computer is set to mark, the ninth bit is always set to 1. When the computer is set to space, the ninth bit is always set to 0. When a device is plugged into the serial port, it is assigned a unique name so it can be accessed. The names are COM1, COM2, COM3, and so on. To find the COM port number that was assigned by the operating system, type Device Manager on your search bar. When the Device Manager comes up, you will easily see the port number. The port name in your code must match the device name assigned by the operating system in order to open up the port. The stop bits are a pause between the data being sent. This is most commonly set to 1 stop bit. Luckily, most of the transmit and receive work is done for you by a chip built into your device. It is called the Universal Asynchronous Receiver Transmitter, or just the UART. When you set up the properties, such as the number of data bits, stop bits, parity bits, and the COM port name, you are configuring the UART. Once configured, you just pass the data to the UART, and the UART will do all the work for you. The device that is receiving the data should also have a UART that will decode the information and pass it along. Once the computer passes the data to the UART, the local UART will communicate with the remote UART. The communication between the 2 UARTs can be transmitted in different ways. One of the most common communication methods is RS-232. True RS-232 communications will use plus 15 volts and minus 15 volts to send logical values. So if you're planning to talk to a 3.3 volt or 5 volt device, such as an LCD, Arduino, or Picaxe, you must convert the RS-232 voltages into voltages that are safe for your device. When talking about electronics and not networking, TTL stands for transistor-transistor logic. TTL logic levels are commonly 0 and 3.3 volts or 0 and 5 volts. This is what is used by most microcontrollers. There are many different devices that will open up a serial port so you can talk to a piece of equipment. Below is an example. The first image is a USB to serial adapter, and when it is plugged into the computer, the operating system recognizes it as a serial port. This adapter outputs RS-232 logic levels. If this cable is directly connected to a digital circuit running at TTL voltages, it would damage the circuit. The next image is a serial DE9 adapter that the website had listed as a DB9 adapter that will take in the higher RS-232 logic levels and convert them to safe TTL logic levels. Both adapters would be needed to be used together if they were to be used to communicate with a digital circuit. If your main goal is to open up a COM port so you can communicate with a 3.3 or 5 volt digital circuit, then you can buy a USB to TTL UART adapter. The example below is equivalent to the cable and the adapter previously shown. These adapters will look like a COM port to the operating system and output the data in voltages that are safe for your 3.3 or 5 volt circuit. An example of the board I use is shown below. I found them on eBay, and you can choose between mini USB, micro USB, or USB-C. Search for USB to TTL UART. The best way to learn is by an example, so let's get started. In order to access a serial port, I'm going to need a serial port. There are many different devices that can add a serial port to my computer. The first device I'm going to demonstrate is a USB to RS-232 cable. Inside this cable is a chip. That chip will convert the USB signals into a functioning UART. The operating system will also recognize this cable as a COM port. If you look at the device manager, when I plug the cable in, you'll see that the cable was added as COM port 7. This cable is outputting RS-232 voltage levels on a DE9 connector. If I were to try to directly connect this cable to a microcontroller running at 5 volts, I would damage it. Therefore, I'm going to need an adapter. The adapter will step down the voltages and give me pins that I can connect to my circuit. Together, these two devices will allow me to talk to a microcontroller. The second device I'm going to demonstrate is a USB to TTL UART. This small board has all the functionality of the cable and the adapter I just demonstrated. This board has the added advantage that it uses a standard USB cable. When I plug the board in, you can see that the board was added as port 10. Using a Picaxe 28X2 microcontroller and a USB to TTL UART, I have built this circuit, so I have some way to demonstrate how to configure, open, read from, and write to a serial port. This circuit has 4 LEDs. When the controller receives an A from Visual Basic, it will toggle the green LED. If it receives a B, it will toggle the red LED. If it receives a C, it will toggle the blue LED. And if it receives a D, it will toggle the yellow LED. The controller also has a 16-pin keypad attached to it. When a button on this keypad is pressed, the controller will transmit the value displayed on the key to the Visual Basic program, where the program will display the value on a text box. This allows me to demonstrate receiving and transmitting values on a serial port. In order to use a serial port, it's important that you open the correct project type. When you select Create a New Project, make sure you select Windows Form App with the .NET Framework. If you do not open this type of project, the serial port will not be in the toolbox. I have opened up a new project named VB22. In order to access the serial port, we're going to have to add the serial port object to our form. Let's go to the toolbox, go down to the bottom, and select Serial Port. You'll notice that the icon looks like a DE9. If you go to the toolbox and the serial port is not there, you probably have opened the wrong type of project. This needs to be a Visual Basic form application that uses the .NET framework. Let's drag the serial port onto the form, and when we do, it will be moved to a bar at the bottom of the screen. That's because there's no visual component of a serial port. There are two different ways we can open up the serial port. The first method I'm going to cover is a very basic method. This method involves just filling in the properties window with all the values I need and issuing the open command. I will be setting up communications with the circuit that is shown in the window. To do this, I need to know what port number my computer will assign it. I can find this information by typing Device Manager in the search window. When I plug in the circuit, the computer will assign it a COM port number. We can get the COM port number by looking under the ports. This device has been assigned COM port 10. So I need to go to the port name and assign it COM port 10. The circuit that I built has a baud rate of 9600. It has 8 data bits. It has no hardware handshaking. It has no parity. And it has 1 stop bit. These happen to be the defaults for the serial port. If any of these other parameters are different with your device, they need to be changed here. Once the device matches the serial port, we can open the serial port. This can be done behind a button or in the subroutine form load. I'm going to do it in the subroutine form load. So I'm going to double click on the form and enter the form load subroutine. All I need to do is issue the command serialport1.open to open the communications port. I'll do this inside of a try catch in case something goes wrong. Let's run this program and see what happens. When the communication is established, you'll get the success message, and then your program will open. However, if I unplug the serial port and rerun the program, I'll get an error message telling me that COM port 10 does not exist. This method to open a serial port will work, but it is unprofessional because you're looking up the port number and hard-coding it into the properties window. If the port number changes, this code will stop working. I would only use this code to verify that the device I'm trying to communicate with is actually working, and I can establish communications. Now that I know my computer will open up communications with my circuit, I will write a more professional version of this code that will give me a list of ports and let me select which port I wish to open. After I finish writing this code, a copy will be available for download. The link can be found in the description below. In this second method to open a serial port, I will add a tab control to my project. The first tab of my tab control will open the COM port and establish the link between my project and my circuit. The second tab will have the buttons and text boxes that will send values to the circuit and receive values from the circuit. Now that I've added and formatted my tab control, I'm going to add a combo box to the first tab. This is where I'm going to list all of the valid serial ports. Next, I'm going to add a button. When I press this button, the project will connect to the COM port that's displayed on the combo box. Now that the first tab is formatted, we can start to write the program. This code will automatically search the operating system and get a list of all the COM ports. In order for this to work, the imports system.management command must be issued above the public class form1 line. After this command is entered, you must go to the project, add reference, scroll down to system management, And when I hover over System Management, you'll see a checkbox appear. Check the checkbox and hit OK. Now you're ready to start writing the code. Inside the form load subroutine, I'm going to call a subroutine called load combo box. Form load calls a subroutine called load combo box. In load combo box, the combo box is first cleared. Next, the number of COM ports is counted. If the count is 0, an error message appears stating that there's nothing connected to the COM port. If it's non-zero, a subroutine is called that will get all of the serial port names and populate the combo box. And if an error occurs when communicating with the operating system, the catch will take over and a different error message will be reported. This section of code could easily be inside of form load, but by making it its own subroutine, the combo box can be refreshed while the program is still running. The Get All Serial Port Names subroutine has two searches that access the operating system. The first part searches for all plug-and-play devices that are acting like COM ports. This is done by querying the operating system using a searcher variable, and then a for each loop goes through the list that's generated and adds the devices one by one to the combo box. The second searcher does the same task, this time looking for hardware COM ports. The for each loop then goes through the second list one element at a time. It checks them against the elements that are already on the combo box list. If an element is already on the list, it is ignored. If it is not on the list, then it is added. A combo box works in a similar way as an array. So the index is set to 0, so the first element is showing on the box. If any error occurs with the operating system, the catch takes over and an error message is displayed. When the project runs and the form loads, the combo box will be populated with all of the valid COM ports. By using the combo box, select the port you want to connect to and press the Connect to COM port button. The code behind the button is shown here. In the first section, the COM port number and the port description that are displayed on the combo box are copied into the string variable COM port. The next 3 lines will remove all of the text except for the COM port number. The explanation of how this is done is in the comments above it. If you've been following along in this series, you will recognize this code. It is the same code that's used to extract the data from a line of text that was read in from an external data file. The second section is assigning various COM port properties. These properties could have been assigned in the Properties window, but by assigning these properties in the code, it opens up the possibility to alter the code so that the baud rate, parity, and other key parameters can be updated using radio buttons. This would allow you to reuse this section of code in multiple projects. The third section assigns a timeout value to the serial port. These values are set to 500 milliseconds each. A millisecond is 1/1000th of a second, so 500 divided by 1000 is a half a second. If either the read or the write function takes longer than this timeout, the port will give up instead of locking up the code. The fourth section is a statement that will close the COM port in case it's open. In rare instances, the COM port may remain open after a program crash. This code will probably never be executed, but it is there just in case. With all of the parameters configured, the port can be opened. Once the port is opened, the tab control is set to 1. This will switch tabs automatically. And as always, this code is inside of a try-catch. If anything goes wrong, the catch will kick in and an error message will be displayed. It doesn't matter if you've opened the COM port using the first method or if you've opened the COM port using the second method. When the program is done, you have to close the COM port. To do this, we'll select the form, go to the Properties window, and select Events. And that's the little lightning bolt button. And we're going to scroll down to Form Closing. We'll double click, and inside the subroutine, we're going to type serialport1.close. This may seem a bit confusing and overwhelming, but take a step back and look at the big picture. When the form loads, it calls Load Combo Box. This routine just verifies that there's something attached to the serial port. If there is, it calls Get All Serial Port Names. Get All Serial Port Names will ask the operating system for a list of available COM port numbers and put them on a combo box. The user can select whatever COM port they wish to connect to. When they press the Connect button, the button will pull the value from the combo box and extract the COM port number, such as COM3, COM8, COM11, or whatever, and it will open that port. Let's run this code and see what happens. When the program loads, we now have a combo box. On the combo box are a list of COM ports that are available to connect to. I want to connect to the Silicon Labs USB to UART bridge on COM port 10. So I'll select that and press Connect to COM port. COM port 10 has been successfully opened. The program will then advance to the next tab. Now that you can open a serial port using method 1 or method 2, we can now learn how to transmit on the COM port. I've added 4 buttons to this form: green, red, blue, and yellow. These will transmit the capital letter A, capital letter B, capital letter C, and capital letter D on the serial port. The microcontroller will receive the A, B, C, or D and toggle the appropriate LED. Let's open the subroutines so we can write the code. The command to transmit on the serial port is serialport.write. The character you want to transmit goes between the double quotes. Let's add the code for the other 3 buttons. It really is that simple. Let's run the program and see what happens. COM port 10 is already selected, so we'll connect to it. We've successfully connected to it, and now we have 4 buttons. Green will toggle the green LED, red will toggle red, blue will toggle blue, and yellow will toggle yellow. Serial port write can also send a string. Let's look at button green. Any string that's between the double quotes will be transmitted. If I were to run the program now and press this button, nothing would happen on my microcontroller. The microcontroller doesn't know what to do with this sentence, so it will ignore it. Serial port write can only send characters, but you may need to send an integer or a byte. There's a way around that. Let's look at button red. Instead of sending B, I can send the numeric value of B that's on the ASCII chart. That's 66. So instead of sending capital letter B, I can send the character 66. Char 66 will take the character representation of 66 and transmit it. This is the way you get around sending integers or bytes down the serial port. Let's run this program and see if button red works. Finally, we're going to learn how to receive characters from the serial port. I've updated the form and added a text box. To receive characters, select the serial port and go to the Properties window. Underneath Events, select Data Received and double-click. This will open up a subroutine called serial port 1 data received. This will automatically execute when data is received on the serial port. First, I'm going to generate a global variable. This variable will be a character. I'll use this variable to store the value that's received on the serial port. As always, I'm going to start with a try-catch. Under the try, I'm going to receive the value that came in on the serial port. I'm also going to add an error message under the catch. To verify I'm receiving the values correctly, I'm going to echo the value I received to a message box right underneath the read command. Underneath the message box, I'm going to append the character I just received to the text box. I'm going to run this program, however, I know there's going to be an error. Let me demonstrate the error so I can show you how to fix it. When I press a button on the keypad, the character that's on the keypad will be transmitted to the Visual Basic project. I pressed an A and I received an A. However, if I try to write this character to the text box, I'm going to get an illegal cross-thread error. This error occurs when the code in serial port data received, which is on one thread, tries to update the form, which is on another thread. However, there's a very simple solution. Any item that's going to be updated on the form just needs to be wrapped inside this invoke command. Now when I run the program, it's going to work. This message box command was used for debugging. I don't need it anymore, so I'm going to comment it out. Now the illegal cross-thread error is gone. When I press the keypad, it's going to update the text box without the error. The buttons are also working. I can toggle the LEDs by pressing the buttons. In this example, I received a character. At the top of this subroutine, I've added 3 comments. These will allow you to make some minor changes that will allow you to receive a byte or a string. In review, COM ports used to be on every computer by default. Now you have to add one to your computer. This can be done using a port that is built into your motherboard, a USB to serial adapter, a USB to TTL UART board, or an HC05 or HC06 Bluetooth to serial module. These devices will create a COM port on your computer. You can get the COM port number by looking in the device manager. A serial port needs to be configured to match the device it is communicating with. You will need the following information to configure your port. This information is given to the Universal Asynchronous Receiver Transmitter, the UART, so it can be sent to the remote device. The UART is specialized hardware that acts as a middleman to make sure your data is sent to the correct destination and arrives safely. If you want to send a letter to someone in another state, you can give it to your local post office. The local post office sends it to the remote post office. The remote post office then delivers the letter to the recipient. This is how a UART works if you want to transmit data to a separate piece of hardware. You give the information to the local UART transmits the value to the remote UART then delivers the information to the destination. The number of wires that connect the 2 UARTs depends on the handshake setting. Most of the time, handshake is set to none. When configured like this, you only need to connect 3 signals: RxD, receive, TXD, transmit, GND, ground. If the signal is on a DE9, these are pins 2, 3, and 5. If you are connected to a USB to TTL UART adapter board, these pins will be marked as RxD, TXD, and ground. When two UARTs are communicating, many times they will be using a method called RS-232. This communication uses voltages that can be as high as plus 15 and minus 15 volts. If you connect these signals directly to a circuit or a device that is running at TTL voltage levels, you will damage your device. If you need to have RS-232 devices talk to a TTL device, you will need an adapter. There are two ways to open a serial port. In the first method, you can load all of the parameters in the Properties window and issue the serialport.open command in form load. This method is mostly used to test a port or to check if a device is working. It is not recommended for a real application. If this method is used and the port number that was added to the Properties window changes, then the program will stop working. In the second method, the operating system is queried and a list of active ports is displayed on the screen. A port is selected and opened. This method requires adding two subroutines to the project and a third piece of code behind a connect button. A text copy of this code is available and a link to it is in the description below. Note, all information and code offered by Dr. DrWedding from any and all sources is offered as is and is not warranted in any way. Once the port is open, you can write to it. This video showed how to write three types of data. If you want to send a single character, you can put it between the double quotes in the serialport.write command. If you want to send a string, you can put it between the double quotes in the serialport.write command. If you want to send out an 8-bit integer, called a byte, you can tell the port to transmit the character associated with that number. If you want to transmit the number 100, you can tell the port to transmit letter 100 on the ASCII chart. You do not need to look up the values on the ASCII chart. You can just use the char command. You will read in values inside of a special subroutine named serial port data received. To create this subroutine, go to the form designer and select the COM port object. Click on the Events button, the lightning bolt, in the Properties window. Double-click on Data Received. Inside the Data Received subroutine, you can read in information that was sent to the VB program. There are a few methods you can use to read in different types of data. Some of these are listed below. When reading in a value, the variable that will hold the information must be the same type as the information. Meaning, if you're reading in a byte, you must store the information in a byte variable. Sometimes you need to cast the variable to a new type before saving it. For example, if you want to save an incoming value as a character, you would issue the command shown below. When you receive information from the serial port, it is on its own program thread. If you don't know what that is, it is not that important. You just need to know that your form is in one place and your received data is in another. If you tell the data received subroutine to update the form by writing to a text box or updating a label, you will get an illegal cross-thread error message. To fix this problem, you will need to wrap the command inside of an invoke command as shown below. Note, some commands may need the refresh command issued at the end in order to work. When your program ends, you should close the port in the form closing subroutine. To create this subroutine, go to the form designer and select the form. Click on the Events button, the lightning bolt, in the Properties window. Double-click on Form Closing. Inside this subroutine, issue the close command as shown below. If you find these videos useful, please like and subscribe. It is the only way I can continue to make these videos.